Here we have a piecewise function, and we're asking if it's continuous at x equals -1. And the function says when x is not equal to -1, we have x squared plus x over x plus 1, and it's simply 2 when x does equal -1. To approach this, we use our continuity checklist. The continuity checklist gives 3 requirements for a function to be continuous at a point. So here our a is -1, right? So let's check through these 3 requirements. Is the function defined at -1? So let's see here. So this is 1, all right. So f of -1. Well, I go back up. This is a piecewise function. And here, right here, it says what happens at x equals -1. F of -1 is 2. So yes, it is defined there. The function is simply 2 at -1. Okay, moving on to number 2 in the continuity checklist here. Number 2 says, does the limit exist? So here we're approaching -1, so I'm going to evaluate the limit as x goes to -1 of this function of f of x. But remember that the limit as x approaches -1 doesn't actually care what happens at the point x equals -1. It only cares what happens as we get very close to x equals -1. So I'm going to focus only on this part of the limit here, this part of the function, and I'm going to ignore what happens to the function at x equals -1. Right? We just want to know what happens when x is not equal to -1, but getting very close to -1. Thus, instead of writing f of x here for the function, I'm going to write x squared plus x over x plus 1. Well, if I just plug in -1 to that, I'm getting 0 over 0. Highly problematic. Let's see if we can get some things to cancel. We can, right? That numerator factors quite nicely, so we have the limit as x goes to -1 of x times x plus 1, and look at that, all over x plus 1, and we get our nice cancellation. Now we can just plug in x equals -1 here, so the limit as x goes to -1 of x is simply -1. Okay, so far so good. Moving on to requirement number 3. In the continuity checklist, we now need the limit as the function approaches -1, so we need the limit as x goes to -1 of f of x to be equal to f of -1. And now we have problems, right? Because the limit we decided was -1, but when we evaluate the function at -1, we decided that was 2, and those are not equal. Okay, so in conclusion, we can write that as 3 dots like that. We conclude that f is not continuous, Okay, at that point, at x equals -1. It's actually continuous at every single other point in the real numbers except for x equals -1, but we are focusing on the one point that this function is not continuous.